Okay, so here is our last section for radicals. And right now you're probably like, oh dear God, get me out of here. But this is it. Now we're solving. Every question up till now didn't have an equal sign. We weren't solving for x, we were just simplifying our expressions. So this is where we kick it up to now being able to figure out what the values of x are allowed to be. Now with radicals, there's a range of possible answers. So we need to first think of restrictions on the domain, which means what are the allowable values of x? And if you were to try to graph root x plus 2, it only exists starting at certain values of x because we're not allowed to have negative numbers underneath the radical. It's a no-no. So you need to check this. Where is x plus 2 greater than or equal to 0? Well, it's when x is greater than or equal to negative 2. So that means you have a domain restriction of negative 2 and up. So if you had a number line, your answers only exist anywhere that way. You can't go lower. So if you were to graph this thing, it wouldn't exist to the left of negative 2. So if you look at this example, first example here, what are the restrictions? Well, you're looking at this. I don't care about this, right? There's nothing on the right side of the equation that prohibits what x is allowed to be. But if I look at the left side of the equation, I can't have a negative number under a radical. So I'm solving when is that greater than or equal to 0. And this is just grade 9 algebra. So 2x is now greater than or equal to positive 3. Divide both sides by 2. X has to be greater than or equal to 3 over 2. So x has to be 1.5 or bigger. The equation does not exist if x is less. If you look at the next example, now in this case, we have two radicals. So we need to check both things. X, we need to satisfy this and this. You can't be negative in either one. So first we'll look at this. 3x plus 4 has to be greater than or equal to 0. 3x has to be greater than or equal to negative 4. X has to be greater than or equal to negative 4 over 3. Now, if you were to look at that on a number line, here's 0, here's 1, here's 2 in the negatives. Let's say that's 1 1/3, so here. Here's negative 4 over 3. I need to be greater than or equal to that. Okay, that's my first domain restriction. But now you need to look at your second one. You have 2x minus 4 also has to be greater than or equal to 0. So 2x has to be greater than or equal to 4. X has to be greater than or equal to 4 over 2, which means x has to be greater than or equal to 2. But 2 is all the way up here, right? And this is my other domain restriction. So how do you decide what the restrictions are? Well, the restrictions have to cover all possible scenarios. So it's where do those lines overlap? So you'll see here, I get green and red. Before that, I don't. And that's not good because that doesn't cover the restriction required for this equation. So you have to go with the one that covers them both. So in this case, only this restriction matters. This one's redundant because it's covered, this one doesn't cover this one. So it's not allowed. You need more than that. You need a sharper restriction. So in this case, you have to go with the x greater than or equal to 2. So let's look at another here. I need to solve this, and I need to solve this. Well, this one's just x is greater than or equal to negative 3. And now here, we go full on grade 9. If you multiply or divide by a negative and you're dealing with inequalities, what do? You have to flip it. So this becomes x is less than or equal to positive 1. So now on my number line here, I got positive 1. I got negative 3. I got 0. For this one here, x has to be greater than or equal to negative 3. Going this way. For this one, x has to be less than or equal than 1. So I'm going this way. So the only region that contains both is the region in between those. So your restriction is between the two of them. okay? X can be everything greater than or equal to negative 3, but only up until positive 1. That's the restriction. We'll talk a lot about this. You'll get lots of practice in class. Okay, so now the juice. Solving. There's an issue in solving because of this. That's true. But if you square something, you can create what's called an extraneous solution. Because if you think about negative 3 equals negative 3, right? And if you square both of those, 9 equals 9. And that's true. But if 3 equaled 3 was your original statement, you would also have 9 equals 9. So when you square something, there's an uncertainty as to whether or not we started there, or if both are allowed. So after you've solved, you need to check to see if the values you've solved for satisfy the given, the original solution. So there's only 2 examples here. I'm going to work through them slowly, but I want you to follow along as close as you can. So if we start with this, we have to square both sides. So you have this. And the written examples are very, very clearly step-by-step walked through. They're nice. So you square both sides. Squares cancels the radicals. You're just going to have x plus 1 here. But you're going to have x minus 1 squared here. So now you have x plus 1 equals x squared minus 2x plus 1. So I foiled most of that in my head, but you're doing this. Okay. And then we're isolating x. So now I'm going to subtract 1 from both sides, and I have x equals x squared minus 2x. And I'm going to subtract x from both sides, and I get 0 equals x squared minus 3x. So if it makes your brain feel better, we'll write it this way, no difference. And then we're going to factor out an x, and then we have this. So we can solve for x. When does this equal 0? Well, when x is 0, or when x is 3. Because if that's 0, the whole thing's 0. If that's a 3, then this whole thing's 0, which is 0. But now we just need to test. So you go back to your original question, and you put in your answers. So for one of them, we had that x was equal to 0. Well, then you have 1 equals negative 1. Is that true? No. So this we reject. It's an extraneous solution. Whereas if we plug 3 in, we get 3 plus 1 should be equal to 3 minus 1. Well, that's root 4 should be equal to 2. 2 equals 2. So this is our only solution, even though x equals 0 existed. So now let's look at the bottom. Okay. This one, it takes a little bit more to solve. You gotta be slow, and you gotta be deliberate with this stuff. So if you start here, this is going to be really disgustingly difficult to square. So get the radicals on different sides of the equal sign. So rewrite it as 2x plus 5 equals 2 plus x minus 1. And then what you're going to do is you're going to square this side and you're going to square this side. But you are foiling the second one. So here we just cancel. We're left with 2x plus 5. I'll be more clear with this one now. I'm going 2 plus root x minus 1 times 2 plus root x minus 1. So FOIL 2 times 2 is 4. And then plus 2 root x minus 1 plus 2 root x minus 1 plus, when this multiplies with this, the radical just cancels, x minus 1. Now if you simplify this, you're going to have 2x plus 5 equals 4 plus 4 times x minus 1 plus x minus 1. So let's get this, this, and this out of this side of the equation. So I'm going to subtract 4 from both sides. Well, first 4 minus 1 is 3, so I'm going to subtract 3 from both sides. I'm going to subtract x from both sides. So you end up with x plus 2 equals 4 times root x minus 1. What we're going to have to do now, though, is we're going to have to square both sides again. Except this time, you're doing this. Okay, so x plus 2 times x plus 2, and then you get 16, and then the square cancels, so but it's times, so brackets, don't forget, x minus 1. So now you get x squared plus 4x plus 4 is equal to 16x minus 16, and we simplify. So x squared, subtract 16 from both sides, is minus 12x plus 20 equals 0. And now, can we factor that? So reverse FOIL, we're looking for two numbers that multiply to 20, add the negative 12, 10 and 2, so you get x minus 2, x minus 10. So we got our answers. X equals 2 and or 10. We've got to check. So come back here. First throw a 2 in. 2 times 2 plus 5. So the root of that, well, that's root 9, equals 2 plus root 2 minus 1. So that's 3 equals 2 plus, well, 2 minus 1 is 1, root is 1, 3 equals 3. Good. So that means this is a solution. And then we just got to check again with 10. It's not always going to cancel out. Sometimes it'll work for both. So we get root 25 should be equal to 2 plus root 9. 5 equals 2 plus 3. 5 equals 5. Yes. So both of those are allowed. So there's a lot going on here. You're going to see more practice as we work through. In a situation like this, get your radicals on either side of the equal sign. Way easier to simplify. But again, this takes everything we've done from grade 9, grade 10, and really makes sure that you have it locked down. So keep working, keep practicing. Workbook here, you'll see you have a whole bunch of practice for these types of questions. Okay? Don't forget to solve for your solutions. And then the word problems, no, did I cover them specifically? I didn't, but that's the whole point, is can you take what you've just learned and master a couple word problems? Think about how it's written. Okay, good luck, enjoy, see you later.